diazonium salts. So the first thing that is under this diazonium salts in your syllabus is preparation of diazonium salt. So diazonium salt can be prepared from aniline. Okay, whenever it is treated with sodium nitrite and HCl, and the temperature is between 0 to 5 degrees centigrade. So under this reaction condition, aniline gets converted into benzene diazonium salt. This is benzene diazonium salt. These two are the byproducts, salt and water. Here benzene diazonium, here it is chloride. Okay, so this is also a salt. Why? Because it stays as positive and negative ion. So this is how you prepare benzene diazonium salt. Now let's discuss about chemical properties of benzene diazonium salts. Chemical properties. The first chemical property is, say here you have, this is benzene diazonium salt and here it is chloride. Okay, this is benzene, this is 2 nitrogen, therefore it is diazonium chloride. Now this as a whole, this group as a whole can be replaced by different substituents like by hydrogen, by OH. Now all these things we are going to learn under chemical properties. The first is by replacement by hydrogen. So whenever benzene diazonium chloride, that is N2 plus Cl minus, okay, whenever you want to replace this with hydrogen, then what you have to do? You have to treat with hypophosphorus acid, that is H3PO2, and water, and you have to use copper ion as catalyst. This is used as what? Catalyst. So under this condition, this is hypophosphorus acid. This is hypophosphorus acid, and this is copper. Under this condition, this group as a whole will be replaced by what? By hydrogen. And whenever it is replaced by hydrogen, we get this benzene compound as the main product. Okay? And your byproducts are S3PO3 plus HCl, and one more byproduct you get, that is nitrogen gas. So here you are getting what? You are getting benzene. How did you get benzene from this diazonium chloride? By replacement of this N2 plus Cl minus group with hydrogen, which is not shown here. You can show it like here. It is bonded with, each carbon contains 1 hydrogen each. Therefore, here we get what? Benzene. From this benzene diazonium chloride, by treating it with what? Hypophosphorus acid. Don't forget the formula. Hydrolysis. What is used as catalyst? Copper ion is used as copper plus 1 positive ion is used as what? Catalyst. Therefore, we get benzene ring. Now let's discuss about the second reaction where this group is replaced by say hydroxyl group. Which group? Hydroxyl group. Replacement by hydroxyl group, that is OH group. Okay, so here to replace this with OH group, you just have to hydrolyze it. Okay, hydrolyze it means you have to heat it or boil it with water, and in water you need to have some drops of sulfuric acid. So whenever benzene diazonium chloride is treated with what? Water, and this water contains few drops of sulfuric acid, and you are heating it to boil it. So whenever it is benzene diazonium chloride is treated with water and few drops of sulfuric acid and boiled, what you obtain? This N2 plus Cl minus ion will be replaced by what? By OH group. OH. And what are your byproducts? Nitrogen and HCl. Nitrogen is the gas. So this is how you obtain this OH group in the benzene ring. It's known as what? It's known as phenol. Now here, for simplicity, you can think it as this reaction has taken as this one. See, this N, this H and H, this H and this Cl has gone as out as what? HCl. This OH group has gone over here and substituted this N2. Now once this OH group is attached over here, nitrogen leaves as what? Nitrogen gas. Okay, this is how you can know how this reaction takes place. Now let's discuss the third. This was the second chemical property. Now let's discuss about the third one, where this OH group in place of OH group, replacement in number 3 chemical property, replacement by, we'll be discussing nitro group. Nitro group, that is NO2. Now here you need to know the names of certain names and formula of certain new compounds. N2 plus Cl minus, this is benzene diazonium chloride. So benzene diazonium chloride, whenever it is treated with fluoroboric acid, that is HBF4. This is fluoroboric acid. Please remember the name and the formula. So whenever benzene diazonium chloride is treated with what? Fluoroboric acid, what will happen? An intermediate gets formed. So here how the reaction takes place? This H and this Cl will go out as what? HCl, say minus HCl has eliminated. Now this, in place of this Cl, this BF4 minus will go in. Okay? So we have N2 plus and BF4 minus. This is intermediate compound. And what is our main aim? Our main aim is to substitute this entire group with what? NO2 group. So in order to do that, what we have to do? We have to treat with sodium nitrite or potassium nitrite. See, we are treating with sodium nitrite. Okay? And here also, copper will be used as what? Catalyst. So whenever this intermediate compound is treated with sodium nitrite, then what will happen? this NO2 group will substitute this entire thing. Okay? And as a result, what we get? We get nitrobenzene. So we get nitrobenzene, and what is the byproduct? Here, nitrogen gas will be formed, and here we'll be getting one more product, which is NaBF4. So here what you have to remember is the formula and the name of this acid, which is fluoroboric acid. It is known as what? It is known as fluoroboric acid. This is the intermediate form. This intermediate form, on treatment with sodium nitrite and copper as catalyst, we get what? We get nitrobenzene, and the byproducts are like this nitrogen gas and NaBF4. Okay, this reaction, please remember it properly, because similar to this reaction, we again have one more reaction. Now, let's discuss this reaction first. Okay. Now, replacement by halogens. Now, these groups here, N2 plus Cl minus, this entire group can be replaced by halogens. Now, whenever it is replaced by, say, chlorine and bromine, we have two different types of name reaction, and it can also be this group N2 plus Cl minus can also be replaced by what? Fluorine. And since just now we have discussed this reaction, and whenever this group is replaced by, say, fluorine, then since these two reactions are similar, so at first we will be replacing this group with what? Fluorine. Okay, that would be more simple. Replacement by, say, fluorine. Now, in this case also, you will be treating this with what? This HBF4, that is fluoroboric acid. Okay, you will be treating with what? Fluoroboric acid, and whenever it is treated, you saw what was the byproduct form? Just now we have done it. This H and this Cl will be eliminated as HCl, say minus HCl, and here N2 plus, in place of Cl, what has come now? BF4 minus gas. Okay, this is the intermediate that we had obtained in our last equation, also previous equation just now. Whenever we were replacing it with what? Nitro. Up to here, exactly everything is same. Now, for nitro, what did you do? You further treated with sodium nitrite. But here, since we are replacing it with fluorine, and fluorine is already present over here, therefore, we just need to what? Heat it. We just need to heat it. Please remember the difference here. You just need to heat it. Whenever you need replacement by fluorine group, you just need to heat this intermediate compound. Once you heat it, you get your desired product, that is fluorobenzene. And the byproducts are, as in the previous case, nitrogen and BF3. So here you are getting what? Fluorobenzene. This is fluorobenzene. So the rest of the chemical, these properties or the reactions, we will be discussing in the next video. Till then, keep revising. Take care.